Welcome again to our module number 8, which will entail automating tasks, and we are going to look at 4 subsections: writing and running do files, loops using for values and for each, macros both local and global, and writing custom programs using program define. Let us dive in the first objective. So writing and running do files. So at this stage, I believe you now are familiar with what do files are. And simply a do file, let us just remind ourselves that a do file is a script that contains a list of STATA commands that can be run as a batch. And some of the benefits why we use do files that because of reproducibility, efficiency, documentation, and many more. And how to create or run a do file: you just need to open the do file editor from the STATA menu, type your commands, run using the execute button, or just do my file and save the output. So that's how we can use log command again also to save our result. So it's a way of automation. We look, and what follows, let us dive into loops now. Loops in STATA are executed using for values and for each, and it is simply used to automate repetitive tasks like variable generation, calculations, or graphs. And for example, this is the syntax. We just need to say for values, and we have the loop representation, and for example, we have here our numeric range of values. And this is the exact example. For values, I is equals to 1/5 curly brackets generate score I. So this simply means that we want to generate values ranging from 1 through 5, and we are telling STATA that it should generate a column or a variable called score, and this score will take on the value of each I, which means each I will be like 1, 2, 3, all the way to 5. And we have now for each loop, we've seen for values, and you need to understand that the difference between for values and for each, that for values is for a single column or a single item, but for each is used to loop over a list, which means you can have a number of variables or columns. And for example, for each var in income, age, education, we're telling STATA to summarize. In short, this line of code, the main objective is simply to summarize each and every variable that are identified here or are specified, such as income, age, and education. We just need the 5-number summary. And now we have macros, both local and global. Macros are, I can say macros can be an equivalent of a variable, but let us see how they are used. So macros are store reusable text or data for later use in the code. So the same thing like a variable does. And we have local macro, which is temporarily within a block or a do file. And example, how we can define a local macro: we use local keyword, local x is equal to 100, and to see what is inside now local x or local macro, we just need to display x, but remember we are displaying it in a special way using a backtick and an apostrophe. So display x, okay, display a backtick, your local variable name, and went with the apostrophe. It will give us what is inside the local variable, which will be 100. And we have now global macro on the other hand, will be available throughout the session. And for example, you just say global y is equal to 200, for example. And to display global, we use $ instead of backtick and apostrophe. So And let us summarize that we used backticks and apostrophe for local variables. That's when we want to declare them now, not declaring but calling them, and dollar sign when we want to call a global variable. And on writing of custom programs, so writing your own program or your own user defined programs. So the custom program using program define will allow the users to define custom commands in Stata, and will allow the users to define custom commands in Stata. And example, this is the syntax: program define, and what follows, you need to give the name of that program, and the name should be descriptive. And for example, in this case, we're giving it as my summary, which means that your program entails to summarize some key variables. And you need to add something called syntax var list, which means that it is expecting a variable list that you need to initialize. And now you need to issue now the same command for each var of var list. You need to list var list, and remember this var list now listed here, so it will reference from this line of code. And again, we are now summarizing the var, this var. Now remember, where is this var coming from? From here. And this var is coming from now officially from here, which is now received from this line of code. And now we need to end our program defined. In summary, in Stata custom programs are equivalent to functions in other language like R, like Python, like JavaScript, like you can say even Excel. And finally, after now, for you to use a function or a custom program, you need now to call it accordingly. Now we can call it like a built-in command, a built-in Stata command. Just need to call my summary, because my summary is that is the exact name or actual name of your program, my summary. And now you add on the var list. This is the var list now from this index. Now age, income, and education. And in short, the moment you run this line of code, it will give you the summary of each of these variables. Now let us see this in practical part. I'm in Stata now, and this is simply the module on automation, but now we are moving to a practical part. So first thing first, let me import the data. And after importing the data, it's time that maybe we can try and see this variable, how the variables look like. We have variables ID, age, gender, income, education, religion, employment, health status, year, as well as survey weight. So, and before we proceed further, we want to understand something called log file. So log file is located here. This is where the log file is located, somewhere here. It's used to record anything that appears in this result window. So anything that appears here will be recorded, even the errors. So, and to put it on, you just need to click on here and you can save. Now let us save that our results, and you can save. And now you realize that it's saying that logs on, and to check if it's if it's working, you just need to click on that button, and you have these three radio button appearing here. So it's telling you the view short of log file. By default, you can close the log file, you can suspend the log file. So let us view. So you realize that it is empty, we've not done anything. And but the moment we issue our first command, we are going to see how that one is going to appear. So let me again import this data and run. And I've run that command. Now let me again go to a log and view the snapshot. Now you realize that we have this line of code. Now it will track all our analytics until the end. Now let us proceed. So let us maybe remind ourselves that a log file will record everything that appears in the result window, and anything that appears in the results window include commands, outputs, error messages, as well as notes. So I hope that is clear to you. And now we have writing and running do file. So far so good. From the beginning to until this point, you understand what is the essence of do file. So do file, in fact, what I'm inside do file. So they'll help you to document your program like a blueprint. So I don't think if there is need, I'm going to re-explain further after reaching at this time of point. So we will proceed to macros, and in this case we are also going to focus on global macros alone. I'm not going to look at local macros. And we need to understand first what are macros. We're just reminding ourselves, and you say that macros are simply like shortcuts, and we use them when we want to store values, just like variables, text, or lists, to reuse them in other commands. And we have two types of macros. We have local and global. And we say local exists temporarily within script or program, whereas global macros are throughout the session or even in multiple files. And the reason why you need to use macros is simply they make our code flexible and dynamic. They reduce our retyping because they save now. They are our shortcuts, so they will replace our redundant code, and they are easier to update values or even variable names in one place. And now looking at global macro, we can have an example. So before we do that, let us browse our data, and we are reminding ourselves maybe, and where the reason why I'm doing this, we want to do something on the region. We have north, south, east, and west regions in this region column. And we want now to create a global macro based on region. You can create a global and give it a name as region of interest, and we give it the real location as north. So let me execute and see what happens. You realize that the command has been issued successfully. So which means at the moment we call the region of interest. Now Stata will understand that this is the north region, and this is the point I told you that macro is simply like a variable, just a container or a placeholder. And now we want to use this global macro in our command. So let us execute this. We are using this list command, id, age, income, if region is equivalent to region of interest. Now remember, we still need to remember that global macro is called by using a dollar sign. That's why I call using a dollar sign here. So I hope so you are not getting confused. The region of interest here. Now which means that Stata is filtering our data based on only guys from the north. So running this command, we'll get only guys from the northern region. And we have alternative command where as well we might run now the guys who are not from the northern region. Now we mean that those from east, west, and south. Now this is the exact representation of those guys. So guys, I hope you understand how you can also use global to do data filtering and making your work easier and trackable. And just a reminder that a local macro is when you want to call it, defining it does not mean that it does not require any special treatment, but calling it you need to use this. Like local, you need to use backtick and an apostrophe, while global, when calling it you need to use dollar sign. For example, if you have the global macro call f, to call it you need to use dollar sign f. And if you have local macro called f and you need to call it, you just need to use backtick f and then apostrophe. And now let us look at another section called loops. So loops, they will help us automate repetitive tasks. Loops help us automate repetitive tasks, and loops will also let us repeat commands multiple times, either over a range of numbers or single columns using for values, or over a list of items or columns using for each. And why are loops helpful? Loops are helpful since they help us avoid copy pasting the same command for different value / variables, and they are so useful since they make the code cleaner, more efficient, and even easier to modify. And now we want to make our hands dirty by now practicing what we've learned in our theoretical part. For example, we need to loop from 1 to 10. And remember, in STATA, if you see 1/10 does not mean a fraction. It simply means 1 through the first number through the last number. And now, in a nutshell, we are telling STATA to create values ranging from 1 to 10, and now we want to display them. Remember, in STATA, we can display those values. We can use the keyword display, and display, in fact, is an option, so you can just use the di instead of the whole thing display, and you can add on your customer's text like this is the loop number, and you pass on the exact ith value, this one, from here all the way to here. So this one will be referent from this line, which means the first position will be 1, the second will be 2, the third will be 4, okay, 3, 4, all the way to 10. So let me execute this line, and you need to see what's happening here. Now you realize that upon executing, you realize this is loop number 1, this is loop number 2, this is loop number 3, all the way to this is loop number 4. I hope you understand how this looping through from row number 1 through row number 10. And now let us see how we can loop over a number of columns. So this is just a single column, but we are here where we can loop over a number of columns, more than one column. So we're saying that for each, remember, if it's a single column, we use for values, and if it is for a list or more than one column, we use for each. So for each var in age, income, and education, we are telling STATA to summarize var. Remember, var is a representation of age, income, and education. So it's simply telling us that to give us five number summary of each of these variables in a single or symbol language. And upon executing this is what we get. On education, I'm getting 0 because education is a string which you cannot get its mean, standard deviation, minimum value as well maximum value. But on income, you have 50 observation, the average is 44,320, standard deviation is 9532.843, a minimum income is 29,000, maximum income 60,000 USDs. And on age, we have 50 observations, that's 6.92, standard deviation 7.761338, and minimum value is 28, which means the 25, this is the youngest guy, and maximum is 53, which is the oldest guy. So moving ahead, I hope you understand that we want to now again to generate to do another example, so maybe you can get exactly what's happening. So again, we want to do, remember we said for values is used to a single column, but for each is used to loop over multiple columns. So we want to create using for values, but we want to modify this for value to create multiple columns instead. So we are telling STATA that I will range from 20 through 30, but we want to generate a new column called age underscore square, and we need to replace with the height. And now again we need to say equals to the value of that I squared. So for example, this simply means, like, for example, we will have to create this column called age, but now for this one, I will represent something, the real value, like will be like 20. So 20 squared, this one will be equivalent to 400, but now it will run through the whole observations. If our data set runs up to 50, then it means that the whole row will be 50. And now we will also have the other columns running from you can say this one all the way to 30. So 30 is the stuff, and will be 900. So before we run anything, let us first of all browse and check what I'm telling you. So we don't have any other column, but I'm telling you we want to create a new 10 columns from here going this way. So let me execute this command so we can be in the same page. So let me first of all execute. Successfully executed, and what follows is, like, we want to check how it appears now after executing. Now you realize that we have new columns ranging from this underscore 20 to all way to underscore 30, age underscore 30. I hope you understand how this command generates those 10 columns. This was just a demonstration, so I think I can do away with it. I hope you understood that. And again, to emphasize, we need again to do some now summary again. We want for each variable in age, income, and survey weight, we want to display summary statistics for each var. So it will be like, we'll have something that will be displayed will be the title for summary for example, it will be summary for age, the next it will be summary for income, the next summary for survey weight, and we'll get a final result. Every result will have its unique title. For example, here summary of survey weight, we have here 5 number summary of income we have here, and we have summary of age, we have it here. Yes, I hope this is clear, guys, and they're interesting. It is difficult to save this table by just copy pasting, like clicking and pasting. Let me try to paste here. Let me just create a new Word document and try to paste here. You see how ugly this one looks like. It looks too ugly when you paste directly. It looks too ugly. Now we want to create to save our plot by exporting directly through a Word document. And to do so, let me show you something. We need to issue this command. To export the frequent table, for example, frequent table of gender, we just need to say as doc tabulate gender, and say comma replace and save my output.doc. So my output.doc will be the name of our frequent table for gender, and we are saying we need to replace if you have a similar plot in where we are saving. So let me execute this, and now we can check from here. We are being told that click to open the file. So the moment I hover here, I realize that it is now telling me to open. Let me click, and voila, here is the table. In fact, it is already in APA format. So you can just click here and copy and present it your result. It is already in APA format. This is nice. You can also create a summary table of income and age, and you can now save it as my output as output 1. So to not override that, so clicking this, it also opens the output, and realize this is the output of the descriptive statistics. So age and income. So I think I clicked twice, that's why I'm having twice here. So this is the summary statistics. What follows now is writing our own custom programs. We've looked at how you can use for loops, how to save those plots, and as well as macros. And now it's time to write our own custom programs. So what are custom programs? In a nutshell, custom programs will let you create your own STATA commands using a program define command. This is a STATA command, as well aware of it, and you can simply wrap this in multiple steps into a single reusable command. And why are they useful? They will help us reduce manual repetition. They will as well make our work modular and scalable. Modular simply means stepwise. Scalable means like we can increase based on if the resource increase, and you can reduce if the resource reduces. And they are great for standardized reporting or analytics workflows. And now let us create our first custom program to summarize and plot a numeric variable. And we want to start with a single variable, using just a single variable. And we say that to create our own custom program, we need to start with the keyword program define, and now the name of the program. And the name of the program is simply clear: summarize and plot. If anyone novice guy reading this can understand that maybe this program, the main purpose is to summarize data and plot, and exactly that's what we're going to do. And now what follows that we issuing the syntax. Remember, in the previous code we issued the syntax like syntax, and then we said varList, but we did not include anything like this, like minimum and maximum. So it was like an open program where we can allow any kind of variable, but here it is not open, like it is for a specific VIP. So we need minimum value will be 1, maximum value will be 1. So in simple terms, we only need a one variable. We can only accept one variable. This is the condition we are setting. And remember, the title is summarize and plot, which means that a plot that can be plotted using one variable can either be a histogram or maybe pie chart. Histogram, pie chart, and sometime maybe bar graph. But in this case, we are aiming to create a histogram. And what follows, we want to show summary statistics. We are saying summarize varList. Remember, where is this varList coming from? From this a single variable that we're expecting from this line. We're expecting a single variable from this line. The moment the user will issue that variable, then it will be summarized here. And after summarizing, then what follows is to plot it. And histogram, varList, and we're saying that his histogram should follow normal distribution, and its title should be a histogram of varList. Are you noticing how this is dynamically being plotted? So it means that varList means that at any point we will be calling our function name, then the title will be changing dynamically. For example, if it is age, it will be the histogram of age. If it is income, will be histogram of income. If it is GDP, it will be the histogram of GDP. So no repetition that will be coming here and again changing title, because if you just know the varList will be replaced here automatically. And now we have to enter a program. And after entering the program, we need to run this program first. And let us confirm that the program has run successfully without any errors. And what now follows is that we want to call a program now using the variable, one variable, and let me execute. After executing, I know it's loading. In fact, we've got the summary here. Now the graph is loading. As we wait, let us wait. Yes, here this is the histogram. This is the plot, the histogram of income. It's already plotted. And as I said, we can change this one to be, for example, age. And you'll also see, first of all, I know we had some summary statistics of age here before we saw this graph, and realize even x-axis changes automatically, y-axis title changes automatically. So you see how powerful custom programs can be. And now we can now again create another program maybe that now can accept multiple variables again. Program define, we need the name of the program again to be my summary. And now in this case, now we are using multiple variables without any restriction. We need just syntax var list, and we're saying that for each var of var list, then var list, then summarize, which means that any variable that we list here, then we just need to summarize them, and we end our program. And remember, if we end this program, it will run, and then it will be expecting us to call it with some of the variables without restrictions here. And the moment I run this, and remember now this program does not require plotting, it just need summaries. And upon executing, this is what you get, just summaries or 5-number summary. Exactly. And this is the end of our section. Thank you guys. Let us meet in module number 9, and which will be our last module. Please subscribe to our channel, and thank you for your support.